Hi there. We're getting closer now to having our API more robust and a solid implementation, and of course secured. Before we get on to that today though, we're going to do some more work briefly on our test-driven development principles. This is the first principles sequence here. This is more like a set of maxims really, or observations that we might make on a well-designed set of tests. It's short enough, but hopefully it starts to confirm your understanding of what TDD is about. We then get into schema inheritance. That is these Joi schemas we're using to generate for us the Open API, the Swagger documentation. Schemas are playing an increasingly important role in JavaScript and TypeScript development. They allow us to put together declarations specifying the structure of important data from which various engines can perform some tasks for us. We've seen how validation can be driven by a schema, and with the Open API Swagger tools, we're generating documentation and indeed a website hosting the specification from schemas. We're using schema inheritance here, which is a little bit perhaps complex to get your head around initially. It does enable us though to build more reusable schemas and also more expressive schemas. We get into that there in the context of tracks, users, and playlists. Okay, with that out of the way, we can get going on our JWT sequence. And here we're going to be looking at the standard first. We can't really use cookies now for APIs that easily. Cookies, remember, live in browsers, and we're trying to develop an API that may be used by a client that's not a browser. Another web application, for instance, or indeed a mobile application. So JWT fills this role that cookies kind of fulfilled for us. And we'll be using them in a similar enough manner, but there's a little bit more work to be done on them. Effectively, it means that every route will support or will require a token. And that token is issued by our API when a user authenticates, and it must be present, it must be born by each request subsequently and checked by the API on each request. JWT is supported by Hapi via some plugins which we install. This means we've got to modify each route declaratively, just by declaring we have a new security strategy. And with that strategy in place, we're effectively just enabling or turning on JWT authentication. So it's reasonably straightforward and direct to implement. A little bit of a revised workflow we've got to get used to, and some tools we have for encoding and decoding tokens. But once we get that in place, it performs a function similar enough to cookies. The tokens will encode information like, say, user ID, which we were using, putting into tokens in cookies in the past. It does mean that all our tests will break though. So it doesn't mean we have to rewrite all the tests, but we have to alter the workflow a little bit. We need to authenticate before we run a sequence of tests, and then maybe log out at the end. And once we make those reasonably small adjustments, all our tests can be brought back into work fairly easily. We'll introduce a new set of tests just to test the authentication mechanism to see that it works okay. Okay, our lab then goes through both of these things. We are going to be looking at the first few steps, getting our schemas in place, and then we'll go straight on to authenticating our routes. Okay, that's it then. So let's get started on our first principles. Another set of these test guidelines then. We structured these a bit like I suppose a checklist, but it's probably not a good idea to look at them as something you've got to check off against all the tests you're writing. They're just a set of general guidelines around how to think about tests and some tips maybe and tricks as we go along, rather than anything we'd have to apply for every feature we're introducing. So we haven't really applied a lot of these principles anyway in our labs, but I think they're useful to tour through because they give you a broad perspective on TDD in general. So this is the last set we look at. This is what they call in this text the first principles. So it's again a kind of an acronym around fast tests, isolating tests, making them repeatable, self-validating, and timely. Some aspects of this have surfaced in the small number of tests we've written. Let's look at the first one, fast. If you've got a lot of tests, and in some significant projects you are talking about thousands of tests possibly, then you're looking at time to run the tests becoming an issue. If you've got this number here taking that amount of time, are you going to run an 8-minute suite of tests multiple times a day? Well, that's going to be a problem, really. 8 might be okay to run periodically. If that becomes 15, 30, well, you're not going to do it, really. And this is the point, really. At some stage, if the tests become too long running, you may have reached a tipping point. And that tipping point means that the tests themselves become less valuable. And if they're less valuable, then you've less confidence in them, and then you may skip running the tests. So they've sort of become self-defeating, really. The tests have become too complex, and the team will avoid running them, or maybe run them very rarely, or at some point, because they're being run so rarely, they become unmaintained, and maybe they never actually pass. So the recommendations are to keep your tests fast. Keep the tests fairly clean and keep the tests as simple as possible. The idea being that the tests are easy to maintain and not creating a burden. If we have a desire for more complicated scenarios to be tested, then there is a whole realm of what's called mock objects. And mock objects is something a bit beyond the scope of this course, really. Mock objects are quite interesting. They allow you the facility to stub out subsystems. So for instance, if we look at the model we've been building and we've been using the kind of facade pattern, we could implement stubs inside here returning fake data from any given model. That is not go to the database, but just return constant data. That would be a mock object of some kind. We could write our tests such that we're expecting that data to come back, and our tests maybe are exercising other subsystems. Mocked or stubbed systems, they're two subtly different approaches, are a way of keeping the tests perhaps fast running and maybe simpler, because they don't have to rely on overcomplicated module relationships. Effectively, we replace some of the subsystem with something simpler so we can test other parts of the system. That's beyond what we're doing, but that's where this type of thinking has led in recent years. Next one then, isolate. I think we see the importance of that at this stage. We're trying to write tests that are cohesive. That is, they're focused on testing one thing, really. They maybe have to do several operations to verify the one thing, but they're focused on one feature we're intending to verify. As you can see, it's very important that the tests can run in any order. So we've taken steps to ensure that in the setup for each test, we clear out the database, in our case, completely. And then it doesn't matter which test runs in what sequence. They should all run completely independently, and they're not going to be dependent on one running before the other. It's very easy to build up that type of subtle dependency between tests. For instance, there might be some data left over from one test which affects the number of elements returned in the next test, for instance. This would lead to a situation whereby the first time we run the tests it would fail, the second time it would pass. These kind of disjunctions are not good, really, so we want to make sure that each test is fully isolated. The single responsibility principle, we might look at that towards the end of the course. It's just a simple, again, design principle around which we construct our thinking around the responsibility of classes. And classes or objects in JavaScript should have only one reason to change. And if those classes or objects are designed with SRP in mind, they do become easier to test. So our test infrastructure, in fact, will often reflect how solid our design has been and whether we've kept a clean, cohesive, loosely coupled design or not. If our implementation has become, to a certain extent, compromised, that it may be untestable to a certain extent. We do always try, if we're relying on databases, to be running a local database, obviously. So we've been doing that. You probably wouldn't want to be running tests against shared database in the cloud, for instance, because there might be other developers testing against the same database. And you can see from the tests we've built so far that they wouldn't really work on a shared data store. Last two then, self-validating. I think this is clear enough, really. When we're writing a test, we've got to use asserts. If we don't use asserts, it's not a test. So in other words, if we're implementing a test strategy, the asserts dictate the confidence level we have in the results. And if we have no asserts, we have no confidence, really. We'd also like the test to be self-arranging and automated as much as possible. This means that it should be possible just to run the tests. We shouldn't have to do complicated setups in advance, running scripts and so on, although maybe that's unavoidable in certain circumstances. But whatever setup is required should be heavily automated as well, so it becomes easy to run the tests. Remember, if the tests become hard to run, they won't be run, and then the effort will have been wasted, and the kind of confidence test gives us will not be available. In more sophisticated environments, a lot of this is heavily automated. So you're writing tests for changes you make. You're checking those into the repository that triggers a build and a run of all tests, and maybe even possibly a rejection of a merge, for instance, if the test fails. This is the whole world of continuous delivery. And it's the idea that built into our pipeline, our build pipeline and our Git merging pipeline would be a test-driven set of tasks that automate the process of ensuring that the tests, number one, are written, and number two, are all passing. Finally, kind of a catch-all one, timely. We are assuming that we can write tests in a timely manner. That is, the tests aren't postponed or written at the end of the sprint or written at the retrospective stage after the sprint itself has taken place, but they're done as the features are being developed. And as guidelines are in place then maybe in some teams to ensure that that test-driven cycle is being maintained. So that's an overview, again, of another set of these principles. I hope they're kind of useful. Food for thought rather than a checklist of things you should be doing at this point. Just notice the last slide there had the word test infected. I might have mentioned this before. The idea is that tests become second nature to the development process, and it becomes as much a part of the development as coding itself. And as much thought goes into the structure of the tests as the structure of the underlying features. We'll try to move our Swagger support just on another level now, because there are a few anomalies in what we've done so far. Let's see how we can tackle them with a slightly more sophisticated structure to the Joi schemas. This library is quite powerful. They say it's the most powerful validator. It's not the only one, of course. JSON schema is becoming very popular now as well, following similar principles. But I think Joi Schema has probably an edge over it in certain areas, at least at the moment. There's a sandbox available on the Joi site, so you can try out some of the schemas you might have and attempt to validate them. It's useful, I guess, to a certain extent, but we've got our test-driven development practices to do more or less the same thing. Remember how the schemas work. We've used them just to validate standard forms, which has been fine, really. But we can also enhance the schemas to generate documentation for Swagger OpenAPI. So this means we've equipped the schemas with some additional infrastructure, including labels and examples. And then we've been able to reuse schemas in the context of arrays, for instance. And this has allowed us to have generated for us the Swagger documentation, which has been quite useful. So if we look at the user API, for instance, this is finding a user. We see that once we've put in these additional features, our Swagger documentation is generating these models, and then they actually contain the sample data we put in, and the structure is interpolated directly from that. Now we've turned on schema validation here of the response. That's enabled us to be able to dip into and generate the documentation. However, as you might have seen in the last lab, that causes a problem because for our model, there's additional information being injected into the objects on return. We're giving back the IDs, and if it's Mongo, there's also a version going back. We do want to send the IDs back, so we don't want to remove those. So this means that if our API is to continue to work, we have to extend the schemas a little bit. So we're extending the schema to include the ID and the version number from Mongo. And now this should work correctly. It does mean, though, that our generated models start to look, well, they contain some extra information which maybe isn't entirely accurate. Certainly it's accurate in terms of returning this information from the user, but it isn't information that necessarily would be required by the user. So when we're creating a new user object, we don't supply the ID and validate and version information, for instance. So how could we start to tackle this problem? Well, we can start by looking at how we can start to reuse aspects of the specifications internally in the schemas. So here I have an example of a new ID spec schema, and then we say the ID is adhering to the ID spec. So we've introduced, in fact, a type here. So the ID spec becomes a reusable specification for a valid ID. That's not necessarily where we go, though, to fix this particular problem. Our problem, if we recap it for a moment, is, let's say this is the post creating a user route. And our documentation currently says that if you're creating a user, here's an example, and your examples should be first name, last name, email, password, and as I mentioned, ID and version numbers coming in here. That's not, strictly speaking, correct. To create a user, you just need the first four fields. You don't need these. These are only returned after you've created a user. This suggests we might need to rethink our schemas a little bit. And we're looking at something like this. We could say that there's a credentials spec, which is just username and password. And there's a user spec, which inherits, that is, it has username and password plus first name and last name. And then we introduced a new one again, user spec plus, which is the user spec plus additional ID fields that are generated or created by our API. And these then use or include an ID. So that's how we might model it conceptually. Base class and derived classes, if you like, from your Java programming days. This is how it would look inside of a Joi schema. User spec, a user credential spec, user spec, user spec plus. We also have ID spec and user array. And we can see there what we're doing. We've got the idea that the user credentials is used or is extended by the user spec. So we've got this coming down, derived from here. And similarly, the user spec plus is an extension of the user spec. It's a little bit cryptic to see, but the idea is reasonably straightforward, and it means that when we annotate our APIs, we're using the correct one. So if we're logging in, it's user credentials. If we're creating a user, it would be a user spec. If we're returning values, it would be user spec plus. So if we use those correctly, And here's an example of us doing that. We would be specifying the appropriate values in the payload and in the validate, and in the response. In validate, it's a user spec. In the response, to be user spec plus. This has the effect then of generating the correct documentation for us. When we're creating a user, we just need the 4 key fields. A successful response will show us the result coming back here. So it's a little bit cryptic to read these, I guess, but the basic idea is that it follows a simple conceptual model of a base type and 2 derived types, and 1 type we are using in that context. So if we follow this, we've got a more accurate now definition of the API namespace. We see clearly what data is expected and what data will be returned. Joi is a way of expressing that information, and it's also a way of that information being validated via the validator that is turned on by us in our application. So not only are we generating the documentation, we have an additional layer here of runtime validation. So if anything goes wrong, it will be triggering errors that we'll have to try and get into and correct. So if the database is misbehaving or not adhering to the schemas we've set up, the API will fail. So we've got quite a robust API evolving here now. We've got a full range of tests. We're turning on JWT as well. And now we've got also documentation and validation also turned on here. We've developed our API now to a certain level. We've got it documented. It's reasonably interesting. And we've got it tested. However, we haven't secured them yet. So anybody who can access our API can do anything they like to the database. We've already implemented some security mechanisms on the application itself, of course, via cookies. So our web interface is secured by cookie authentication strategies, and that's been working fine. But cookies aren't really available if there's no browser. And our API may not be accessed via a browser. So we would need some technology that's independent of browser features. And a de facto standard in this world is JWT, JSON Web Tokens, which we look at now. We'll pose it as a series of questions. We've got to go back a little bit before JWT to HTTP authorization in general, bearer authentication, and then JSON Web Tokens, how they're structured, what's in them, how do they work. Starting with authorization, HTTP has an authorization request header, which is something we can use in this context. It's a separate header with the word authorization in it, an authorization scheme and authorization parameters. It's part of the HTTP standard. And the idea is that this is extensible. So we've got these 2 fields we can insert, and we might, for instance, have a very basic authentication with username and password here, or we could have something more sophisticated. And the more sophisticated thing would be to use bearer authentication. So this would be the same header again. We'd have the word authorization provided when we were making each request. We'd have the keyword bearer, and then we'd have some kind of token. So if we're using bearer authentication then for our API access, if the token is valid, the request is satisfied by the API. If the token is not valid, it will be rejected. If you've used any open source APIs like the Open Weather Map, for instance, a form of bearer authentication is being engaged there, in that we're providing an API key, which is the token in that instance, when accessing the endpoints. So where does this leave us? Well, bearer authentication is a standard specified in OAuth 2. And OAuth 2 also has some other interesting recommendations around what the token should look like. I'm not going to go into great depth in OAuth 2, just going to look at the basics to allow us to get up and running with our API. And JWT is where this comes from. It's a standard for defining the structure of the token. And we structure a token as a JSON object. So it's very friendly for developers to develop, create, and consume. And the JWT standard defines what should be in the token, how we would create it, structure it, how it would expire, how it would provide various useful information in the context of a web application. So it should be compact and self-contained. And we use it in the context of authentication, but also possibly information exchange. So we're going to be sticking that JWT token directly on each of our messages when we're authenticated into using an API. And the token can contain information we would like to be exchanged between the client and the server. So they can be used in contexts slightly beyond just authentication. So what do they consist of? Well, three parts: header, payload, and signature. And these are encoded as three long strings separated by dots. So it's one big long series, looks like a hexadecimal sequence of characters separated by dots, and they're all encoded. And we can build up those tokens using a standard hashing mechanisms and standard libraries, and we can decode those tokens to see what it is has been inserted. So the header, two parts usually: the algorithm and the type of the token. Type is JWT in our case, so that's the standard we're using, base64 encoded. And there's a range of standard popular algorithms that are available and can be inserted in here. The payload, the second part, contains what's called the claims. These are statements about the entity, typically the user. So think of it as metadata. There's reserved claims, public claims, and private claims. And the kind of things we're putting in here really would be information that can identify the user specifically. The third part then would be the signature. And this was where the crypto comes in, really, allowing us to cryptographically sign the token. So what might it look like? Well, here is an example, a token here. You can see we've got some sort of name, admin is true or false. Maybe that's indication about the role of the user, or maybe the ID of the user, the algorithm being used, the type of the token, and then the encoding takes place, and we end up with the three strings below separated by dots. Various tools available online to encode and decode these. So for instance, if I put that string into this website here, I'll be able to see or get back the original token. These are some more examples, different algorithms specified here, claims here, including the issuer, the scope, expiry date, for instance, and the signature. This information, we'll be using just standard fields in our examples, but there is an agreed vocabulary here, which you may be adhering to. So the issuer, the expiry, for instance, sub is used to indicate the potential user ID. So as we've said, we create a token based on information that we determine to be relevant, and we insert the token on each subsequent request. In the context of our application, we'll be introducing an authentication step, if you like, inside our app. When a user issues a post to log in, under cookie authentication, we check the username, password, and we set a cookie. We'll follow a very similar pattern in our Hapi application. When the user attempts to log in an API, we'll specify a new route for this. If we've got a valid username and password, we will create a token and we'll send the token back to the client. Client must then remember that token and use it on all subsequent requests, more or less mirroring the way cookies work. Cookies are transmitted on every request in this manner. We'd also be relying hopefully on our Hapi framework to abstract a lot of this for us, so we don't have to do a lot of the heavy lifting. And in fact, we follow a similar set of strategies to the ones we've already implemented with cookies. So they're convenient, compact, and secure. We could invent our own scheme to do bare authentication, but the JWT is reasonably widely accepted. So that's the one we're going to use and implement in our project. So how do we plug JWT facility into our application for authenticating the API routes we've established? As I mentioned, we already have a security strategy. It's based around cookies. And the mechanism for introducing and enforcing cookie authentication can be redeployed to secure the API routes. In other words, we can use the same mechanisms. We've got to do a little bit of extra work to encode and decode the tokens, but overall, the amount of additional facilities to be incorporated into our API to adhere to JWT standards is fairly minimal, as we'll see shortly. So as ever, we're relying on libraries. So we'll be looking at some JWT node libraries for encoding and decoding tokens. We'll need a new route to authenticate a user, so effectively creating the token and giving it back to the client. And then we need to turn on security for all our routes. Well, maybe not all of them because the user has to log in, but for most of them. And then we'll address testing the routes. We already have a mechanism for testing our API. How does bringing in tokens impact on that? The libraries then first. We have a choice here of libraries. There's a fair few of these in NPM. We'll use JSON Web Token. This is an independent of the framework we're using. It's just a library that gives us functions for encoding and decoding, or signing as we call it, JSON Web Tokens. So that's the first one. Second one will be a Hapi plugin. So Hapi Auth JWT2 is a plugin that will allow us to create a new strategy that will adhere to some of the JWT principles. We'll look at both of those now. The JSON Web Token has sign method, and it's got a full range of support for all the features of JSON Web Token standard. We're not that interested really in getting too deeply into this for the moment. The basic ones we need really are some way of encoding some user identification information, let's say user email and ID, and also some kind of expiry, and also what algorithm we're going to be using. We'll be able to deploy that then in a function we will write called create token. So this is a function we write, and the function will take a user object, so somebody in the database. We'll extract from the user object their ID and email, put that into a token, and sign it up here. So you can see we're getting the user ID here, putting it into this payload. We're also establishing the algorithm we're going to use and an expiry of 1 hour. And then we're signing the token and returning that as the token we've just created. Notice that we are using the cookie password as our key here. We could maybe have a special one for JWT, but we've already got the cookie password set up, so that'll be fine for the moment. So that's the first function. This will create a token for us from a user object. Second one would be to decode a token and give us back the user info part of the payload. So we're verifying the token, getting a decoded version back. So this is the method that decodes the token effectively for us here. We're getting back what we put in, so we should be able to recover this information, and we pass that back as the value of the function. So that gives us basic infrastructure we need to get up and running. One more function then we'll write, validate a token. And this is where we hook into the Hapi system. We've written a function like this for the cookie authentication. We'll reprise that in a moment. But the validate function we'll write here will be receiving a decoded token, and from that decoded token we'll be attempting to see if that user exists, if it's valid, and if it is, we'll insert that valid user into this object we return here as the credentials, very much mirroring what we did in cookie-based authentication. So incorporating this then into our Hapi application, we do a number of things. We import and register the plugin. We create a strategy which mirrors aspects of the cookie strategy, which we'll recap in a moment. And then that strategy will be triggering this validate function for every route that is associated with the strategy. This means then we must create a token in some authenticate route. Here is where we're going to create the token. So a new route whereby we'll be expecting a user's username and password to be delivered. When they are delivered and we've validated them, we create a token and then we return that token. So you can see that token is being sent back here to the client with a 201. So we're authorized. And that token then we are going to be expecting to be sent to us again for all subsequent requests that are going to be validated against this strategy. Just a quick recap on cookie authentication. Remember, when we log in a user, we set the cookie, and this is driven then by an authentication strategy we've created for all our routes, which is the cookie authentications being defined as the default strategy here. This means that for every route not marked with anything different, the session strategy will be in play, and it'll only be possible for that route to be accessed if there's a session created with a valid user. That's validated by the validate function, which looks up the ID of the user and creates a credentials object. So we've done all this already. We annotated routes, the accounts routes, with auth false, so we turned it off for our accounts because we had to allow a user to sign up and log in, obviously. But then we left the strategy out everywhere else on all our playlist and dashboard controllers because we wanted all those to be validated. For JWT, we're setting this strategy, as we've mentioned, and this strategy will allow us to have this new version of the validate function to be invoked for each of the routes that are JWT annotated. And that is a new strategy with a new validate function. And that validate function is going to decode the token and create a credentials object for us, which we can access in any of the secured routes. So all of that means that if we've installed this new strategy, we just annotate all of our routes with strategy JWT. And that's all we need to do. Keep the routes exactly as they have already been defined. But with this authentication strategy JWT installed for each route, they will now be automatically all secured. Won't be possible to access any of these routes unless a valid token has been provided. So this means that all the work we've done in terms of the schemas and the Swagger and related all still holds really, but we've got this new layer of security defined for the application. So we still have a bit more work to do in terms of testing this, and also it does have some implications for how the Swagger tools work because they're now requiring a token. We'll tackle the testing anyway first. Before we get into the testing of our routes, imagine for a moment we just introduced JWT authentication and we had no unit tests. Well, we have quite a lot of work to do now to verify that we got this right. We might be using Postman. We might be writing some other clients to test it out. We've had a bit of work to do to scaffold up those tests, and we would have quite a bit of work to do possibly in Postman to see if the token was in fact encoded, decoded correctly. In other words, if we didn't have a TDD infrastructure, exercising a major change like this, which is securing all our routes, would have been very challenging, and we probably wouldn't have had an exhaustive verification that the routes hadn't destabilized the system or weren't implemented correctly. So it's in major changes like this that TDD starts to really pay off. We've had to do a bit of work to get TDD up and running, but now we've got the freedom and the confidence to make major improvements to the application in the knowledge that I have a safety net here of tests that verify whether I've gone off track or whether everything is working as we predicted it might. So these tests are very important then. We've got a full suite of them being established now, all our API tests anyway, at least. We're exercising playlist, track, and API. And because we're introducing a new feature, we do it incrementally. So we introduce a new set of tests here, the API tests, we might call them. Now, what would they do? Well, we already have a playtime service object, as you might recall, which is our interface into all of the API. This seems like a good place to centralize any work we might need to do on authentication. In other words, we could equip that playtime service object with an authenticate, let's say, method, which would ensure that the tokens are set up and are used for all subsequent exchanges. Remember, we're using this bearer authentication technique, which is part of the HTTP standard. So we would expect our Axios library to help us out here. And here is how we could do it. A new function called authenticate. We call this and we provide, let's say, a user object. And we're expecting that once we've authenticated, all subsequent requests to our playtime service object for creating playlists, creating tracks, and so on, all of these we're now expecting will be authenticated once we have called this once. And the way we do it is we access the authenticate route we've implemented here. So we're doing a standard post to this standard specification of the user. It's very much like a login route that might happen from a form, for instance. But we're expecting a response to give us back the token. And the token should be in data.token. And we install inside Axios for all subsequent requests the authentication header, the authorization header rather, bearer plus token. So this means that all subsequent requests now will include the token we got back from our authentication request. Clear auth would be a way we log out, so we would just reset it to blank. And here is how our test might look. In our setup, we delete all users. In our authenticate, we create a user, authenticate with that user, and here we're verifying that we got a successful response and that we got the token. We might do one more test here to look a little bit more deeply at it. Again, create a user, authenticate, and then we might decode the token and see does it actually match the user we've attempted to log in. So we're doing some deeper testing here of the facility we've implemented. We should also check that the routes that we'll pick one at random here that are secured can't be accessed now unless a user logs in. So we will make sure we're not logged in. So we do a clear auth, and then we attempt to access, let's say, delete all users. That should fail because we're not authenticated, so we should never get here, and we should get a 401 here. indicating that we're not authorized. So if we do that, we've got verified that our authentication now works, and we can then turn our attention back to all the other API tests. Now, hopefully that's not going to be too painful. It should largely be a matter of going to our fixture setups. And here what we're doing is we are clearing the authentication, creating a user, clearing out all of the data. So we're making sure our tests are isolated. When we do delete all users, we'll have deleted the user we just created. So we need to create the user again, authenticate, and then the test should run as before. So all our tests would roughly match something like this. In our setup, we'll create a user and authenticate, and then all the tests will run in the context of that authenticated user. Follow that pattern, we've got a reasonable chance that most of our tests should work. We might have to tweak one or two tests, particularly if we're doing any delete all users inside any of the tests. I think that's happening in one or two cases. We'd have to just rethink that a little bit, because deleting all the user will delete the currently authenticated user as well, so it'll cause subsequent APIs calls to fail. So we'll see that in the lab. But in general, it's a few small tweaks and all our tests are up and running again. So what we will have at the end of this exercise will be the complete test sequence running. Again, if you contemplate for a moment bringing in JWT without having test-driven development in place, we would have a tough slog at this point to verify that it does actually work as advertised. Here, because we structured our tests to always use the encapsulated playtime service gateway object, if we call it that, then we just need to modify that, putting in the authorization headers in an authentication function. And all our tests will work more or less as before. A few tweaks here and there, but the tests should all work. But they're all now, of course, properly guarded by JWT strategies on the server side. The tokens are going over and back. They're being decoded each time and verified. So we've got a fully secured API at this point.